So in the last section we were talking about the ordinal scale, and this time we need to talk about the interval scale. And the interval scale consists of ordered categories that are all intervals of exactly the same size. So temperature, when the temperature is 0, does that mean there's no temperature? An arbitrary 0 point, that is the value of 0, is assigned to a particular location on the scale just as a matter of convenience or reference. And then interval scales are relatively rare. So you might have Fahrenheit and Celsius degrees, golf scores like above and below par, or relative measures such as above or below average rainfall. The ratio scale, that's the same as the interval, but with an absolute 0 point rather than just an arbitrary one. And in this, you might do a ratio for the number of aggressive acts, with 0 being no aggressive acts occurred. And then in the Bobo experiment, a child that hit the doll 10 times would be twice as aggressive as a child that hit the doll 5 times. And granted, this might be somewhat simplified. You could argue that the force with which the child hit the doll was important, but you get the idea. At some point, there has to be, if we're going to do a quantitative, there has to be um, a simplification that goes on. So the difference between the interval and the ratio is if you took the height of everyone in your class. So ratio would mean no height, and then you convert the height to a z-score. So the average height equals 0, and 1 would mean an inch above the average, etc. And that would be an interval scale, because 0 does not mean no height, and someone with a score of 4 is not twice as tall as a score of 2. Does that make sense? Sampling is pretty interesting. There's no way that we could sample all of the individuals of interest to most populations. Um, so if you were wanting to do a study on visualization and sports performance, my population might be pro basketball players or Olympic gymnasts. And I would probably just find a subset of that population. We can't do the whole human population because we're looking at more than 6 billion people. So if generally they just find a subset of the population to use as a sample. And the population can be large or small depending on what you're studying, but you're still never going to study the whole entire population. So what we use is a sample, and that's usually a set of individuals that are selected from the population that's intended to represent the population. So if you had a garbage can filled with marbles of 4 different colors, blue and green and red, there are different numbers of each color of marble. To get a good idea of what proportion of marbles are each color without counting all the marbles, you could just take a sample. I'm going to stop here because the next slide shows a really neat graphic that I want to talk about.